Hi all and welcome to another episode of Labbing It. In today's video we are going to start with part one of a two-part series where we're going to configure NetApp into our environment. We're actually going to install a NetApp appliance in our production environment and also one in our newly created DR environment. Basically we're going to use the NetApp Simulator which is downloadable from the NetApp website. I think you just need a user account, a NetApp user account to gain access to it. Um, and I've actually found this to be quite useful in my learnings. I'm not a NetApp expert by any stretch, but recently I was tasked to configure Veeam with a couple of NetApp appliances, so I thought it might be good to just video this up. Um, so basically what I'm going to do is I'm going to download the NetApp Simulator. Actually, I've already pre-downloaded. I've downloaded a recent release of the simulator. And what we're going to do, we're going to install it into our Melbourne site, our production site. The first thing we'll need to do is just reconfigure the virtual disks that come by default with the NetApp simulator. The NetApp simulator, and I'll show you in the lab, um, comes with a bunch of 1 GB disks, about 30 or so of them, giving us about 30 GB of usable storage, which in some aspects might be enough to do a little bit of playing around, but I wanted to sort of use it a little bit more thoroughly. And I found some guides where you can delete these 1 GB disks and replace them for 10 GB disks, so giving us around 300 gigabytes of usable storage. So we're going to go through that process, and then basically we're just going to configure one of the storage appliances in the Melbourne site, bring it into the network, create some NFS storage and present it to our VMware environment. Once that's complete, we'll migrate one of our virtual machines to the NFS storage, and then we'll integrate the NetApp appliance with Veeam. And much like a previous episode, we'll test the whole process with a Veeam backup from storage snapshot. And this will lead us into part two of this two-part series, where we're going to put another NetApp appliance in our disaster recovery site, and pretty much pair them up, the NetApp devices between the two sites, and play around with snapshot replication from one site to the other, which is really useful for disaster recovery. We'll also play around with backups from a secondary storage snapshot as well. So that's another useful tool that can all be done and conducted through Veeam. So let's jump in the lab. There's a lot to go through in this video, and we'll get started. Okay, so here we are in the lab. Now, to get the simulator, there is just a website you can go to. So it's just on the mysupport.netapp.com website. And once you've organized yourself a login, you should be able to download these simulators. Now, I can't remember whether or not you have to be some sort of partner level or need partner level access to get to these downloads. I've seen other articles, and I think people can download these freely. If you can't get it hold of here, I'm sure you can find it somewhere on the website, on a website somewhere to gain access to it. Somebody will have a copy of it. But basically, what I have done is downloaded this version here, the ONTAP 9.12.1. You can see there are a few recent versions: 9.10.1, 11.1, and 13.1. I've played around with all of them. I've just found, I don't know if it's just specific to my environment, to my lab environment. I just found that 9.12.1 worked the best, and performed the best. So I downloaded this version, and this is the one that I'm going to install in our lab today. So you download it in an OVA file, which I think is open virtualization application. So that means that this file can be opened up in VMware or VMware Workstation, as in our case, and then it can be fully deployed. So let's do that now. I'll get back into my lab environment, and basically what I'm going to do is, actually you might not be able to see that, I'm going to bring that across just a fraction and go open, and I'm going to go and find where I downloaded the OVA, which I think would be just in here. As you can see, these are a few of the different versions I've played around with. 9.12.1 is what I'm going to start with. So I'll go open, and then it's just like deploying a virtual machine. So I'm going to call it NetApp 1, Mel NetApp 1, and I think I will install it on my E drive and just hit import. Actually, I'll just change that from Big Lab to Labbing it, and then go. There we go. Make sure it's in the right folder. Okay, import. So this doesn't really take too long, and it will pop up here at the top. So this is pretty much the virtual machine ready to go. Now, if you've been following along with my videos, so anything that you see along here in this top row, so these ESXi servers, VSA, VBR, Linux repository, tape exchange, and so forth, all of these, for all intents and purposes, they're considered physical machines. I know that they're virtual, but just from a lab point of view, they're considered physical machines. And what I mean by that, I guess, in a bit more detail, is that this is the overview of our lab environment, and we're really considered with what's going on inside VMware Workstation there in the right hand side. So we're playing around at the moment with the Melbourne network, the 192.168.10.0, where we've got a bunch of these virtual machines, which you can see, which you just saw at the top of my VMware Workstation. And we've also configured a secondary site in a previous video, so our .20.0/24, which is our Sydney site. And we're going to be pretty much building that environment out with ESXi hosts and so forth for DR purposes. And if we look a little bit deeper, this is kind of the Melbourne network as it stands. So we've got all those physical machines under the LAN segmentation called Melbourne. And we also have these ESXi hosts down the bottom, ESX1, 2, and 3, which is for our virtual environment. But everything along the top is considered our physical servers. And if you look on the far left, I've added in Mel NetApp 1, which is going to be our new installation that we're going to do today. So let's go back to the lab. And let's edit the virtual machine. So that's the first thing we need to do. Now, the first thing I'm going to do is this hard disk number 4. So I'm pretty sure all the simulators will install with this configuration. And what you see here is not actually what's fully reflected inside the simulator. My understanding is that that the simulator will install with a bunch of, I guess, virtual or logical disks. And they are actually stored on this particular disk in the virtual machine, which is this one here at 230.7 gigabytes. Because I'm going to change the default disks inside the NetApp simulator from 1 gig to 10 gig, I'm going to expand this out just a little bit. Actually, a lot. I'm going to double it pretty much. I'm going to just expand it out to 500 gig. It's all thin provisioned, so you don't need to worry too much about capacity as of right now. But this is going to allow me to expand these logical disks in the simulator out to 10 gig without worrying about filling up this disk. So I'm going to hit the expand button. It will be pretty much straightforward because it is thin provisioned, and done. And then the other thing I just need to concern myself with is these adapters. Now, for the purpose of this simulator and for this lab environment, I'm only actually going to use one NIC. So the one NIC is going to be the management address. It's going to be our node address, our cluster address. It's going to be used for NFS and all the rest of it. So pretty much everything's going to be used on one of these NICs. It's actually going to be this one here, this network adapter number 3. The other 3 NICs, I'm not going to be worrying about. I'm not going to delete them because I don't know if that causes any problems with the simulator. I followed a few different guides, and basically what I do is I'm just going to create, I'm just going to configure this called NetApp cluster. You can call it whatever you want. You can create a new LAN segment, call it whatever you want. I'm just going to put all these on NetApp cluster. But within the in this simulator, we're not going to actually really configure them for anything. This NetApp is also going to be just a single node cluster, so I'm not going to be doing 2 node clusters. There are some good videos out there that show you how to do the 2 node clusters. I'm only going to be doing a single node cluster for this setup. And for adapter 3, I'm going to put it on the the Labbing Melbourne network, which is the management network that pretty much everything else is attached to. And that's pretty much it. So when we get into the simulator, you'll see that there's 4 interfaces. There's EOA, EOB, EOC, EOD. That's a representation of these 4 NICs. We are going to be playing around with EOC. So that'd be A, B, C, and D. We're not going to configure those 3. It's just going to be this one. And you'll see that as we progress in. So let's hit OK. And now we can just go ahead and power up the machine. Now, if you are using one of the most recent versions of the simulator, I think the 9.10, 11, 12, and 13, all you need to do is just let it power up until you get to the start screen. So you don't need to do anything else, just let it do its own thing. And once it's powered up, we'll continue from there because we need to configure, the first thing we need to do is configure the disks. Okay, so I just paused the video there just for a few moments. It took about 3 or 4 minutes to boot up. I didn't do anything, I just let it run its course and it finished up here with the login prompt. So it's also got a DHCP address, as you can see, 10.102. We're not going to be concerning ourselves with any of that just for the time being, because the first thing, as I mentioned, is that we're going to fix up the disks. So the default user account is admin, and there's no password at this stage, so it logs us straight in. So the first thing we do need to do is configure the admin password. Now, we're actually going to do this twice, because what we're doing right now is configuring the disks, and then we're going to kind of like blow this the software away and let it reconfigure itself with the new disks. This is kind of the process required if you want to expand the disks. If you don't want to expand the disks, then you don't need to follow this procedure. You can catch up with us at a later stage where we are configuring the node and the cluster. So let's fix up these disks. So the first thing we need to do is actually add a password to this admin account. So security login password, username admin, current password, there isn't any, so I just hit enter, new password. So punch in the password and again, done. The next thing is that we need to unlock the diagnostic account. So security login unlock username diag, done. And then we also need to set the password for the diagnostic account. So I'm just going to go up a couple of times here. Security login password username diag. Sorry, spelled that wrong. Diag, and enter the password. Now we're done. Now we need to set our account to a privilege, an advanced privilege mode. So we set privilege advanced. Done. Yes. Now from here on end, I'm not a NetApp specialist, so I don't know exactly what it is that I'm necessarily doing here with some of these commands. I followed a couple of different guides. They do exactly the same thing. If you want to change the disks on these ONTAP simulators, then this is the process to follow. So we're in a privilege mode, and now we're going to just follow up with some commands. So the next is set diag. Now again, like I said, I don't know exactly what these do. I'm just following the commands as per some of the other documents that I've read. So now we need to get into the system shell -node local, and then we enter the diag password that we just created. And now we're in the system shell, and in here is where we can manipulate the disks. The first thing we need to do is set an environmental variable, and this is the command. what I might do, I might try and put these commands in the description just so that people can easily copy and paste them. If manipulating the disks is what you want to do. And then I change the directory. And this, I believe, is the directory for all the disks within this simulator. And the way that I read this, I believe, is V0, V1 might be the shelf number. So I think these simulators come with, I guess you'd call four shelves. Obviously, they're logical because it's a simulator. And I think each shelf can hold a maximum of 14 disks. Now that might be completely wrong. That's how I've played around with the simulator, and it's based off the notes that I've found from other articles. But what you see there is a whole bunch of disks, and the important part there is in the middle where you can see 1000 megabytes, so 1 gigabyte. So that tells us the size of these disks. And what we're going to do is actually delete all these disks and create a bunch of new disks at 10 gig in size. So to delete them, all I run is a sudo command, remove, and basically I'm just removing anything that starts with V0 and V1. And there's also another, I think what we also need to delete is this reservations folder, sudo rm reservations, and that's it. So pretty much this folder is now blank, apart from shelf disk shelf 14. And then we just change the directory again. And now we are going to create these new disks. And how we create them is based off this list, which you can actually show yourself. vsim underscore make disks space -h. This shows what I believe is 38 different disk types. I'm not actually concerned with the first 14 that we don't see, so we don't need to see any of those. You can see this list. I'm assuming if you know the commands, you can probably show the whole list. But I'm only interested in the disks down the bottom. So these are all the disk types that you can create. So we've just deleted all our disks. Now we need to create a bunch of new disks. The left-hand number all the way down to 38 is the type number. And the type number that we're concerning ourselves is with type 36 down near the bottom. And if you look towards the middle, you can see that it is of size 9.4 or so gigabytes. And the disk type is a FZ520. Now, I don't think performance is really going to be an issue here because this is just all virtualized. So I don't think it really matters too much with what disks you do choose, but that is the highest capacity disk on offer. So I'm going to choose 36. So to create these disks, there's a command that we type in. Now, as I mentioned before, there are 4 shelves in this simulator. So we create the disks and assign them a shelf. Each shelf, I believe, can have a maximum number of 14 disks. So we have to run this command 4 different times for 4 different shelves. So this is the command: sudo vsim make disks. How many disks is -n? We want to create 14 disks because 14 disks, I believe, is the maximum. What type disk we want to create? It's type 36, as we've already mentioned. And then -a is for the shelf number. And the shelves are numbered 0 through to 3. So we start with -a space 0 and hit enter. And then it creates 14 disks. And all we need to do, I just press the up button and just change this to shelf 1. I just want the same disk type on all the shelves. So basically I get a total of 56 disks. Shelf 1 and shelf 2 and shelf 3, which is actually shelf 4. And that's it. I've just recreated the disks. So if we were to go to this directory again and do an ls, now you can see that I have a bunch of new disks. So I think V0, V1, V2, V3 are the shelf numbers, and you can see that they're all these. Well, they're not 10 gigabytes. They're kind of 9 gigabytes in size. So that's it. That's all ready to go. So to get out of here, we just hit exit, and we do a reboot, and say yes. We'll let it do this reboot. So what we need to do now is get to the boot menu for this appliance. So we don't want it to actually boot up again. We want to get to the boot menu so we can perform a clean configuration. And the timing for that needs to be perfect. So here we can see hit enter to boot immediately. That's actually okay. We want to do a boot, but not actually boot up, because we're going to get another option to press Control C. And it's right now. As you can see there, press Control C for boot menu. So I have done that, and down the bottom there, boot menu will be available. Now, if you miss it for whatever reason, I'm pretty sure you can just reboot the NetApp and give it another go. All I want to do here is choose number 4, clean configuration, and initialize all disks. You may see some other, if you see some other videos around YouTube and maybe some other websites and blogs, they might show that they go into maintenance mode first. I haven't found any reason to do that. Actually, every time I go into maintenance mode, it doesn't seem to work in the simulator. So I just go to clean configuration and initialize all disks, and it's been fine for me. So I hit 4 and press enter. And it's just asking if I want to zero the disks out, which I do, and then it's just going to make me confirm, and I'll hit yes. That's pretty much it. This process will take a few moments, and the NetApp will reboot itself. So when we come back, we'll be at a position to actually create the or build the node and build the cluster all through the command line. So I'm just going to pause the video and let this complete. I don't need to do anything. When I get prompted next, I'll start the video back up. Okay, so that only took a couple of minutes. This is the first prompt that I've received, and it's just talking about auto support. I'm going to just say yes to enabling it. If I say no, I think in the graphical interface, you keep getting warning messages. So I'm just going to say yes. It doesn't really do anything, so I'm not too concerned. Enter the node management interface port. So as I mentioned before, everything's going to be on EOC. So the node IP, the cluster IP, NFS, the intercluster IP that we create when we need to talk to the secondary NetApp, it's all going to be on EOC. So I'm happy with that. You can either type it in, or if it's already showing as EOC in those brackets, you can just hit enter. That's the default. And now it's just asking for the IP address. So this is for the node. And I think what I have back here in our diagram, so on the far left there, you've got Mel NetApp 1. The node IP address is 192.168.10.5, and the cluster IP is 10.6. You still need a cluster IP, even though that this NetApp is going to be a single node cluster. You still need to provide a cluster IP, I believe. So we'll still go through that process anyway. So 10.5. So 192.168.10.5. The subnet mask is 255.255.255.0, and the gateway is 192.168.10.1. And now it's asking if I want to set up the cluster, which I do. So I'm just going to hit enter. And it's asking, am I creating a new cluster or joining a cluster? I'm just creating. Again, it's only going to be a single node. I'll get the option next. Do you intend for this node to be used as a single node cluster? Yes, I do. If you select no, I believe that's when you've got to set up a bunch of additional IPs and so forth. But this is just a simplistic installation. Now it's asking for the cluster admin account password, so I'm just going to type that in. You can't see that I'm typing it in, I'm just typing it in and then retyping. And now it's asking for the cluster name. So I might, let me just check my notes, what I was going to call the cluster. Yep, I'm just going to call it Mel NetApp Primary. And the other node that will be created in the Sydney site will be just Mel NetApp Secondary. Mel NetApp Primary. Hit enter. And now it's just going to create the cluster services. This doesn't take too long. Okay, that's all done. Now it's just asking for license keys. I'm not going to worry about that for now. We do need to put some licenses into the NetApp in order to use all the features that we want to use, but I'm not worrying about that now. Now it's just asking for the cluster management interface port. Again, as I said, it's EOC. So by default, it's showing EOA. So I need to change that to EOC. It is case sensitive, so be mindful that you do EOC. Of course, if you want to use EOA and you've configured your network in the right manner, then obviously you can use EOA, but I'm just doing it all under the one interface. And now it's asking for the IP address for the cluster. And again, if I just go back to my diagram, it's 10, so node was 10.5, cluster is 10.6, 192.168, 10.6, and the same subnet mask, it's a 24-bit, and it's asking for the default gateway. It already knows that it's most likely going to be 10.1, so I just hit enter to accept 10.1. That's asking for the DNS domain names. So in my case, jtairlines.internal, and my server IP addresses for DNS. Now, I think you can put multiples here. I think you can go 10.4. Actually, I'm going to try it because when I was playing around testing this before doing these videos, I only had one DNS server. I do actually have two, 10.10 and 10.14. I'm just going to put a comma and see if that works. Doesn't seem to be complaining about it, so that's all good. Where is the controller located? It's located in Melbourne. And we do not need to worry about the backup destination. We're not doing any of that, so hit enter. And that's it. It's somewhat configured, especially from a network point of view with the IP addresses. Now, there are just a couple of things before I log into the graphical interface. There's a couple of things that I do here in the CLI. So I'm going to log in. and I'm going to configure my time zone. So if you go cluster date show, it gives you by default a UTC time zone. I'm going to change that to a local time zone. So to do that is cluster date modify dash time zone. And then basically, depending on where you are, I put in my country. Actually, if you don't put a country and you hit tab, it'll give you a list of potential locations. So in my case, I put in Australia. And then if I hit tab again, and then I get a bunch of options for Australia. So I'm just going to put in Melbourne and hit enter. And if I go cluster date show again, now that's been altered to the correct time. Now that is showing the 20th of February, 1:30 a.m., which is not the current time. And we need to be mindful of this. We need to make sure that the time is perfectly set up. So when we do integrate with VMware and Veeam and with other clusters potentially, we need to make sure our timings are perfect. So the way I'm going to fix that up now is through NTP. And if I go to cluster time service, NTP server show, the table is currently empty. So we're not running any NTP service. So to manipulate that, cluster time service NTP server create dash server. Now I use my ISP's NTP server for pretty much everything. I found it quite reliable. So mine is ntp.internode.on.net. Now this is just if this fails, it's most likely just DNS not working. And sometimes I just have to do it a second time and then voila, it works. So if I go hit the up a couple of times and just do a service show, now I have an ntp.internode.on.net NTP server. Now this apparently can take a little bit of time to update. So if I go cluster date show, I know it's already updated. So it's the 19th of February, or I don't like it that it, in Australia, we read our dates the other way, 19-2-2024. So that's the 19th of February, which is right now, and it is 229. And I can confirm that if I just show you a little bit more of the screen. There you can see there, 19th of February 2024, 2:30 p.m. Okay. That's all I wanted to do in the CLI for now, but it's not the last of the CLI. We will be using it for some other setups. So what we're going to do now is jump into the graphical interface. So let me jump out and let's get into the PC. Okay, in we go. All right, so I'm just going to open up a web browser, and just to reiterate, we are going to connect to the cluster IP. So we will rarely ever need to access the node IP. So the cluster IP is where we'll do all the management from here on end, which is 192.168.10.6. Just punching that in there, sorry. Here we go. Warning messages. I think this is something new with the more recent release of the simulator. I'm just going to say not now. I'm just signing into the system manager. I think there's now a cloud-based management platform. So log in with the admin account. Now the first thing I need to do is assign all the disks to what they call an aggregate. So there are 56 disks in this storage appliance. 3 gets taken up for the operating system, so that gets automatically completed. It's 3 random disks, but it gets automatically done during the configuration phase of the ONTAP operating system. And under cluster, under disks, we can search for those 3 disks. So it's these 3 here. They've been assigned to the operating system, so we can't really do anything with that. They've been assigned to an aggregate. So an aggregate is, I guess at a high level, is like a pool of storage to be consumed for volumes that you might create and present to say VMware or to Windows or whatever it might be. So this is like a default aggregate that gets created, or default tier. I think the word aggregate and tier in NetApp get used interchangeably. So what we need to do with the rest of the disks is create a brand new aggregate or tier. And the first thing we need to do before we can do that is assign all the unassigned disks and spares, if we see any, to the actual NetApp cluster. So what I'm going to do here is select all the disks, and normally what you should see here is an assign link, but the reason we're not seeing that at the moment is just because these have been selected, because these are already assigned. Now we see the assign. And all I'm going to say is assign to node. So sorry, not clusters, assign to the node. And it's going to assign this node, all these disks, which is what we want. If we went ahead and tried to create a new pool of storage, we wouldn't be able to, because there's no disks available. So this is just a prerequisite before we create our first pool of storage. And just waiting for that to complete. I see a few down here. Okay, all right there. Beautiful. So now we can see here under owner, all these disks have an owner, which is good. So I'm only showing the first 20, so I just need to click over into the next page. There's probably a better way to do this. But again, I'm just going to highlight all the disks. So in the second page, and I can just click assign. Don't be too concerned if you see or spares and unassigned. So we can highlight all spares and all unassigned and just assign them, even though the spares are already assigned. So this is just a quick way to do it. It's only the ones with aggregate that we can't touch. And that one's done. And we just hit to the final page, so the remaining disks, and assign. Just waiting for these last few. And done. Okay, so all the disks, so all 56 of the disks are now assigned. 3 have already been consumed, so we've got 53 left that we can use to create what they call is a storage tier or an aggregate. I think they've just changed the naming. So here we don't see anything. There is obviously the operating system tier, but that's kind of, I guess that's kind of hidden, so we don't really see that here. In the CLI, I think we could see it. So what I normally do is I actually don't use the GUI to create this. I just jump back into the to the CLI, and I'll just log back in. And I'm going to create a new pool of storage, a new aggregate. And the command for that is storage aggregate create. And then we give it the name. I'm just going to call it primary aggregate, just shortened down. Disk count. So how many disks do we want to add to this? Actually, I'm just going to drop back for a second. I'm going to just list the disks first. So storage, disk, show. Actually, if I just go like that. We also, so when we do create the aggregate, we have to nominate the disk type. So all 56 disks have been created as type fcal. So we just need to make sure that that we use fcal as the option. If we had SSDs, we would see SSD disks. We don't. They're all the exact same disks from when we created those disks a little while back. So fcal is important to remember. So let's go back to creating the aggregate. Create, and I'm just going to call it main ag the disk count. So how many disks for this aggregate? 53, because that's what I know. So I'm not going to have any spares or anything like that. I'm not too fussed about that. You might obviously in a real world situation, but for the simulator, I'm not worrying about it. And I just need to add the disk type, which is fcal. If I type something else, if I try to use a different disk type, it will tell me that I don't have any of those available, so I wouldn't be able to run this command. And the other thing, you don't have to put this in. I think by default, the RAID type is always RAID DP. So I think that's just a NetApp form of RAID. So it will create this aggregate with a few parity disks as well. So I'm going to hit enter. And basically, it's just going to give me a list of all the disks that are going to be assigned to this aggregate, which is pretty much all of them. And if you just hit spacebar a few times and you get to the bottom, do you want to continue? Yes. And now it's going away and creating the aggregate. Done. Now, if we jump back into our graphical interface, maybe if we just click away and click back into tiers, now we see a new aggregate with 356 gigabytes of available storage. Done. So that's the first bit complete. So next thing I want to do is just assign my licenses. So the licenses, I guess you could say they're just individual. There are individual licenses that gives you certain features within the NetApp. So if we go to cluster settings, and here we see licenses, I'll just open it up. And here you can just see all the features available for licensing on this storage appliance. And all I'm going to do here, I'm just going to add a license. So to enable a whole bunch of features that I might want to use. So this license file, I think it's a default one. I think it's exactly the same that everyone gets when they download the simulator. So it's not a license file. It's just like a legacy set of keys. And I'm just going to paste that into there and go add. And all of a sudden, a whole bunch of these feature sets now become compliant and available to use. So obviously some things here I'm not going to be using. We're really interested in NFS and also some of the snap mirror, snap vault features as well for replication. So that's pretty simple. So now we are licensed. Okay, so the next thing to do is we need to create an SVM, storage VMs. I think they were otherwise known as vServers in previous releases of ONTAP, but now they call it SVMs. And we kind of need this in order to set policies, I guess, within our NetApp environment. So again, I'm not a massive NetApp expert, but we'll see once we add an SVM what I'm actually sort of alluding to. So I'm going to give it a name. What name can we call it? We might just call it primary SVM. And I'm not going to enable anything right now. We can do that after the fact. You can create an SVM administrator. So if you wanted to give administrators specific access or only access to this SVM, but nothing else from an administrative purpose on the actual cluster, we could tick this box. So this is kind of like role-based access, basically, just providing particular accounts to only managing this storage VM. So if we click save, just wait for that to complete. Okay, now if we go into the storage VM, as you can see, there's nothing really configured. We have a look at the settings. There's a whole bunch of different settings in here that we can configure. And really, for the purpose of this video, the two things that we kind of really only concerning ourselves with is export policies. So when we create an NFS volume, we want to export that NFS volume to our VMware environment. So we need to create export policies to kind of lock down who gets access to what. And we also want to set up the NFS protocol. So what I'm going to do first, I'm going to fix up the export policy. Now, there's a whole heap of literature on this, and there's a lot of videos and a lot of experts that talk about how to do these export policies. I'm not necessarily going to follow the best practice. What I'm essentially going to do is assign the default policy access to my ESXi hosts. So I'm going to punch in the management addresses of my ESXi hosts because NFS is going to work over the management network. So they're my three ESXi hosts, 10.21, 10.22, and 10.23. You can uncheck these because I'm not going to be using SMB. I'm not entirely sure what flex cache is, but I am going to be using NFS. And in particular, I'm only going to use NFS 3. And essentially, I just fill up the access. So basically, these VMware servers will have full access to the NFS storage that I'm about to configure. So click save and done. Again, there's probably much better practices on how to set up these default policies. My understanding is actually when a client tries to connect to, say, the NFS storage, they'll check the default policy first and make sure they pass the default policy, and then any other subsequent policies gets checked after that. So I'm kind of just bypassing all that and just saying, hey, default policy, these three VMware servers, ESXi servers, have full access on the NFS v3 protocol. Now I'll go back to our settings. So now I've got my default export policy with this rule in place. And now I'm just going to configure NFS. And that's just here. So go to settings. Now it's asking what IP address. Now if I go back to our diagram, and I had it here, so on the left hand side there, Mel NetApp 1, down the bottom, NFS IP 192.168.10.7. So that's what I'm going to punch in here, 192.168.10.7, subnet mask 24, 10.1, and save. Okay. Now I need to create the NFS volume. Now I typically will do this through the CLI. So we've enabled the protocol, we've enabled the export policy, which is the default policy. So now I'm going to create the volume. So I'm going to do this in the CLI because I think you get a few more added options. Let me just check. If I go here and go add test, I just want to just check because I'm not sure if I've created one in here. Default policy, snapshot copies. Actually, no, let's do it here. Okay, I'm just going to call this vSphere NFS. I'm going to make it 100 gig. I'm not going to check any settings here. I am going to export it via NFS. Which policy am I going to use? I'm going to use the default policy. I'm not going to use any snap lock, so I think that's around immutability for our snapshotted volumes. I'm not going to worry about that, and I'm not going to enable any protection. And click save. Actually, before I click save, I'm pretty sure, so if you do want to know what that command would be from the CLI, pretty sure it says volume create. We nominate the V server, so that's the storage VM. If you press the tab button, it's going to automatically populate the only storage VM which we created, primary underscore SVM. I think then we need to add the aggregate name, which is main aggregate, and then volume. Oops, not sure what's going on there. It's not having some issues. Why is it doing that? Let's see if that works. Volume. I think we're going to call it vSphere underscore NFS. Rule index. You have to put a rule index. I think something's gone wrong with the. Let me just run that again. Volume create vServer primary SVM aggregate, the main aggregate, the volume, vSphere NFS 1, or vSphere NFS. Sorry, not rule index. We just want the size. Rule index pertains to policies, so you can go 100 gig and then nominate the policy, which I think is just default. And the last thing, I'm just checking my notes as I'm writing this, because what I don't want is no snapshot policy. So you can also say snapshot policy none. So, and one last command, junction path, which would be just the name of your volume, and I think this creates the folder for the NFS volume under the root volume of the SVM. So back here, if you go have a look at, let me just cancel that for a second. We have a root volume, so as soon as we create an SVM, we get a root volume. The junction path just pertains to the folder within the root volume where we are going to run this actual NFS volume. So let me just, might just hit enter here. See if that creates exactly what I want. Okay. And now we have that volume vSphere underscore NFS. It's so it's 100 gig in size. It's got the default policy, and this part here is the all-important component, so the NFX access. So what we can do now, I think that's pretty much it in terms of creating this NFS volume. So this is ready to be presented to the vSphere environment. So I'm just going to log into my vCenter. And what I'm going to do here is, I'll just snap back out to here. Might go to Melbourne cluster. because I want to add this NFS volume to all three of my hosts. So instead of doing it individually, which I could, I can just go up to the cluster, go storage, new data store. It's asking what type of data store. I'm just going to call it, I'm just going to select NFS and which version, NFS 3 and the data store name. So I'm just going to call it exactly the same, vSphere underscore NFS. That's what I called it on the NetApp. And then it's just asking for the folder and the server. So if I click across here, it's really just asking for these details here. If I just do a copy and paste, and if I just put the folder details there, so I will cut that out. So that's the folder / vSphere underscore NFS, and then the server, which is 192.168.10.7. Let's get rid of that. And let's go next. And where do I want to assign it? I want to assign it to all three hosts, and go next, and go finish. And as you can see then, they're in our recent tasks, all completed. So if I go to MEL-ESX1, for instance, and have a look at the data stores, I now see that vSphere underscore NFS storage, which is located on our NetApp system. So that was pretty simple. So there's nothing really else we need to do just for this part in terms of the configuration of this primary NetApp system. The last thing I was just going to do is, actually there's a couple of things because we're going to integrate this into Veeam. So I'm going to migrate this virtual machine MEL sub CA. I'm going to migrate that with a change storage only. So it's a vStorage or vStorage vMotion, I think that's how they call it, to vSphere NFS. So it's currently residing either on one of these two data stores or all the components of this particular virtual machine. We're going to migrate it onto vSphere NFS and click finish. And I'll give that just a moment to complete. I might just pause the recording because that could take a few minutes. Okay, so while that's actually completing the migration, let's jump into our VBR server and let's configure the storage infrastructure. So like in a previous video, when we're testing backup from storage snapshots, we added in the SAN of our existing store virtual, where all our virtual machines currently reside. Now we're going to add this new NetApp system. So at the top, add storage. So last time we did Hewlett Packard Enterprise because it's a HPE store virtual. This time we are going to go to NetApp, and it is in data on tap. And now it's asking for the management server DNS name or IP address, which brings me to a good point. I'm going to, so we called the cluster name. Let's go back, oops, not here, back to our PC. Let's just check the cluster name, which is MEL NetApp primary. What I'm going to do, I'm going to update DNS. And not in that zone. New A record, MEL NetApp primary, and the IP address, just to reiterate, so it's the cluster IP 10.6. And hit add host. Done. And that should replicate across to our other domain controller. So if I just quickly do a test here now, ping MEL NetApp primary, that responds to 10.6. So what I can do here is go MEL NetApp primary.jtalliance.internal, and it is block or file storage for VMware. That's the role. Next, we need to add the credentials. So I'm just going to use the admin cluster credentials. Okay. Certificate security alert, continue. And then it's going to ask me what protocols do I want to use. So this is just NFS. You can get it to create the required export rules automatically. I'm going to say no to that. So basically, it will go into our export policies and update the policies to allow, I guess, this VBR server and proxy servers access to that to the NFS volume. I'm going to do that manually. Volumes to scan. I'll just choose all volumes. Some people say get rid of the root volume because the root volume will be included, but I'm not going to worry about that. I'm going to leave it in there. Backup proxies to use. It's going to be this one that I'm going to allow access, just like we did for the store virtual. Mount server I'm not too fussed about. And go apply. And run storage infrastructure rescan. That's fine. This will actually pull the NFS volume into here, but I think we'll get a message potentially. I know we're not going to say anything. NFS share. No, that's all good. Okay, I was expecting maybe an NFS warning because the proxy server doesn't have access to it. So let's go close. We can open up here. So there's our SVM, primary SVM. As I said, it's going to show the root volume as well, which is okay. We're not really worried about that. But here we have vSphere NFS volume, which is great. So that's all fully integrated. So what I'm going to do, just going to jump back to my PC. Just going to quickly ping the proxy server just to get the IP address. proxy1 10.19. I'm going to go to the export policy. So I'm going to go to storage, VMs, primary SVM settings, and down to export policies, which is here. I'm going to open that up. I'm going to go into default. Again, this may not be best practices. I'm going to edit this rule, and I'm going to add 192.168.10.19/32. If you're wondering why I'm adding the /32, I found just during my testing that it was a bit of a hit and miss if I added it in or didn't. So I never had an issue when I've added in the /32. So that's the only reason why it's there. It may be different in your simulator or in your real life NetApp environment, but that's what I've done to make sure that it works. That's just updated the policy. So this should allow the proxy server to access the NFS volume to do the required backups. So let's go back into our VBR server. Actually, I think the first thing, I'll just check, make sure that relocate virtual machine is complete. Beautiful. Okay. Back to our VBR server. Let's create a backup job. Okay, so backup. Let's create a new backup job. So new virtual machine backup. I'm going to call this, let's just call it NetApp Backup. And add virtual machine. I guess if you're in an environment with multiple SANs, you may want to use the data store option as a way to dynamically add virtual machines to backup jobs. So essentially any virtual machine that lives on a particular volume will get backed up in this job. And that might work well because if I want to do something specific, as I'm going to be doing with the NetApp, with the NetApp appliance, because I'm going to put a secondary one in the DR site, we may just want to focus our attention just to the NetApp data store. So I'm going to do that for this job. And as you can see, this data store has one virtual machine. And add. I'll go next. I'm going to choose my main proxy server. So I'm going to back up to our Veeam hardened repository for immutability. I'm going to configure GFS. And then I'm going to go into advanced and make sure that we are enabling backup from storage snapshots. So that's important. I'm going to leave these three unticked. I've mentioned this in a previous video, but I don't want, especially this one, I don't want to fail over to standard backup. I want to make sure that a backup from storage snapshot works. And go, oh, I might just show you this in this video. I'm going to configure secondary destinations for this job. So as a primary function to this backup job, we are going to back up all the workloads on this data store to this particular repository. If I click next with that option, I have some additional options here with regards to ONTAP. So I could set up like a backup copy job. So any VMs being backed up in this job should be also considered to be backed up in for instance, a backup copy job. I don't actually have one of those in place, or I could back it up to a tape job. I'm not going to do that. What I want to do is an ONTAP snapshot. So here we've got snap vault, snap mirror. These are two different functions which we'll talk about in the next video, in the next part of this series. This only really works if we have another NetApp appliance to work with. We only got the one at the moment, but what we can do is actually perform what they call the ONTAP snapshot. So in addition to the backup going to our hardened repository, we can also tell the NetApp to say, keep a copy of the snapshot that you make for this backup job and keep it for a certain amount of restore points. So maybe I'm happy to keep the next 2 snapshots, and I'll show you what happens on the NetApp side of things. So if I click OK and go next, and I do want to enable application aware processing, I'll just use the standard administrator credentials. Next, and I will run this job. Let's just run it at say 7 p.m. each day, but I'm going to run it now. Run this job, and let's monitor. Now hopefully it works first time. And we'll just see what happens. Here we go. Infrastructure resources have been assigned. Preparing the VM for storage snapshot. So if I just close, if I click OK here, if we go down to here, what we will see under vSphere NFS is a snapshot. Ignore what you see up here on the root. That's an automatic snapshot being made by the NetApp as part of the default policy for root volumes. I think we'll see a bunch of snapshots occur for the root volume. We're only interested in the NFS. Come back, just see what's happening. Okay, it's been created successfully. This one, okay, it has shown. So here's a Veeam source snapshot. And if we go to our NetApp and have a look at what's happening to our NFS volume and snapshot copies, and we can see there's an auxiliary one. So this is for the backup job. And I believe that this is going to be for retention. So this will disappear once the backup job completes. This one will stay for retention. So we've told the job, keep the latest 2 snapshots. So let's go back into the VBR server. Just see what's happening now. So it's now processing the backups. It's sending this data off to the hardened repository. And as we can see down here, it is, I'll widen this up a little bit, retrieving hard disk 1 from the storage snapshot. So we definitely are doing a storage snapshot backup. I'm just going to pause the video, wait for this to complete, and we might just run this a couple of times just to see the process of the ONTAP snapshots. This first backup will just take a few minutes because it's a full backup. I'll pause and we'll come back. Okay, so that's completed. So no errors, backup from storage snapshots, everything looks like it's worked just fine. If we just come back out here, if we have a look at our backups, we can see that now we have a NetApp backup on our Veeam hardened repository. Here we can do a myriad of restore functions, but we also have snapshots as well. So here we have more limited options because it's based on snapshots and what we can do with snapshots. But nonetheless, we can still perform certain recoveries without any issues. So we can still do an instant recovery of this virtual machine, or we can restore guest files from the virtual machine if need be. And another view of that is under here in storage infrastructure. Here we've got that snapshot that it's going to retain. So it's going to retain the most recent 2 snapshots, and here we can see the same set of options. And note here, it's telling us that it's an application consistent snapshot because we enabled application aware processing. Veeam is able to orchestrate with the NetApp to do an application consistent snapshot, which is really cool. So what we might do, I might just quickly run the job again. This should be a lot quicker now that we've got that full backup under our belt. So I'm just going to hit start and let it run again. This only finished just a few minutes ago, so the changes should be pretty minimal. Most of the time will be just the processing stuff. So even preparing the VMs for a storage snapshot, that's probably going to be the longest task of this run. And again, if we jump out over here to our system manager, what we should see shortly is another snapshot pop up, actually probably another 2. So it'll be another source snapshot and an auxiliary snapshot for the backups. Just waiting. There we go. So this one for the backup and this one for the secondary snapshot. So it's going to retain these 2. And when we run the job a 3rd time, basically it's just going to do what typical retention is. It's just going to remove this first snapshot and it'll have this one and the new snapshot. Let's just jump back into the job because it's probably going to be finished in a second. Here we go. And that auxiliary snapshot should disappear. So flicking between the 2, yep. So it's left these 2. And we're complete. So if we have a look at snapshots, now we have 2 restore points, so we can restore from either one of those restore points. Our disk now has 2 restore points, and obviously now we can see these 2 snapshots right here, which is what we see in the system manager. And if we were to just run this one more time, just for sake of being pedantic about how this all operates. So what we should see now is this snapshot taken at 11:04. At the end of this job, this snapshot should be deleted. It's pretty cool, to be honest, what Veeam can do, and obviously it's worked. They've worked really hard with the various storage vendors to allow for this integration, because typically, you know, storage administrators will manage um, snapshot copies and mirroring these snapshots to other NetApp appliances, for instance, and they manage that all through um, the system manager for ONTAP in this case. But the fact now that, if you are an organization that might be using Veeam, and as long as you are licensed, I think you do need like the Enterprise Plus licensing, or the highest tier licensing in Veeam to use these features. You can actually manage all of that from the Veeam console. Just requires for the storage administrator and the backup administrator to work together. I mean, there could be one and the same person, but to set up the storage devices, and then it's just, then it's just a matter of getting Veeam sorted and getting Veeam to um, you know configure the storage integration, and then set up the backup jobs and set up all the replication of snapshots. And we'll see a little bit more in the second video, how that all ties in when we do some replication using SnapMirror. So this job's just about to be completed. Let's just go back here. So we've got our new 1121 snapshot, and there we go. The auxiliary and the 1104 has been deleted, and I think we'll get some notification in the backup job that a snapshot has been deleted for retention. And obviously, if we, in the backup job, if we said we want to keep 14 or 20, you can keep as many as you want. Obviously, whatever retention requirements you have, and what storage you have available to allow you to keep those snapshots. But like I said, it's all managed here through the Veeam. So Veeam is now managing all this for us. And then, as I've said in a previous video, when we talk about replicating these snapshots across to another storage appliance, that's going to set us up for our disaster recovery strategy. So we'll go through a video and install Veeam Recovery Orchestrator, and we'll tie all this in and have a look what it looks like from a disaster recovery point of view. But that's all completed. Backups are working. The first NetApp is in. So in our part 2 of our video, we'll go ahead and quickly set up the secondary NetApp system and connect up the two NetApp devices together to allow us to replicate between one another, and we'll integrate all that into Veeam. So for now, thank you very much for watching. Stay tuned. I'll have the second video ready.